This garbage bag, I have 100 pop cans. They're all Pepsi and Diet Coke cans. So I'm going to melt them all and see how much aluminum it produces and see if there's enough there to justify melting it rather than taking the cans in. Always check your apparatus first before you try turning the gas on. Make sure everything works. Okay, so make sure that all your levers are closed. This is open and down is closed. All right, so they're closed. I'm going to turn the propane on. I'm going to open the bottom valve first. You can hear the propane. And there she's on. Now, I'll put my crucible in there. This way. Try and get it so it's sitting in there, basically center, or center as possible. Alright. And now I'm going to crank it right up. Put one can in now. Now we'll wait for that one to melt. And then I'll leave the video on while I put some more in and watch them melt. Okay, as you can see, it's getting hotter, but that can is still down in there and it's not melted yet. So the whole crucible has to turn red hot, and then everything's going to start melting really fast. It's red hot, or hot enough that you can watch the cans melt right away. I'll turn this off for now and do the 100 cans, and then we'll try pouring and see how it looks. One nice looking ingot. You have to try it, try to make it level. There it is with the lid down. Got 100 cans in there. They're all melted. Very hot, hot, hot. Well, that didn't turn out as good as I wanted. I missed half of the crucible. After the first time, you melt all those cans, you get this kind of thing. And you can see there's small bits of aluminum still all through this. So this has to be broken up and remelted again. And then you get pretty well most of the aluminum out of it. The leftover after this is this kind of stuff. It's hard, brittle, usually left on the bottom of the crucible, you know, and kind of sticks in there, something like this, that piece down there, sort of thing, you know. And it's hard, but it's very brittle. And I'm not sure what it is. Breaks very easy. Well, that one doesn't. But yeah, I broke it right in half. So I don't know what this stuff is. So usually from this, then you get down and you get this kind of a leftover after you pour out the runny stuff. And now this has to be melted down too to get the rest of the aluminum out of it. So you're going through these stages to try and get all you can for aluminum out of everything. And this here paper thin stuff usually cakes the side of the crucible when you're pouring. It's paper thin, sticks to the side, doesn't come right out, cools off. And when I did this last pour, these are the pieces that missed the crucible altogether. So it's got to be redone again. I mean, missed the mold altogether, not the crucible. And this was the ingot. Not very good. Pretty poor. Very poor. I have to redo it again. It's just under a pound. Sometimes these things take time to figure out. With me, it always takes time to figure out. It's just my luck. Anyway, so that's all we got from there. So, start again. And by the way, my good camera is back on the tripod and is working now. I don't know, it's like a woman sometimes. It's got a mind of its own. All right, here we go. Okay, so I'm going to see if I can melt the rest of the stuff that was left over. Time to pour. Should be the last time I have to do this. Oh, let's give it a try. Good. There we go. From those 100 cans, let it cool off, and take it and measure it, and see what we get from 100 cans, 100 pop cans of aluminum. Final product. Okay, we're going to weigh the empty cans, and then we'll weigh the aluminum ingot. .014, 0.014,
Believe it or not,
0.014.
one of the world's most technological hubs. Finland was the first country in the world to make broadband internet for all a fundamental right.
Well, there's always an asshole. It's pretty well .014. Let's try it again. .014 for the Pepsi.
That's all the finish I know.
.012 for the Coke.
I work for Nokia.
.014 for the Pepsi. All right, well, I guess the Pepsis are
Has a mobile phone, or should I say,
.012. Wow.
it's actually the country in Europe where there are the most
Fucking thing.
devices per person. It isn't a rare thing to see people with 2 or 3 phones, sometimes for work, or for the younger generation, if they want to keep family and friends.
Fuck's sakes.
Oh my god.
To Helsinki, we
Oh
found
my
Oh,
god.
that's stupid.
They're changing sizes overnight.
Shut up.
someone told me.
Oh my god.
I'm filming, she's laughing at me. .014 for the Coke.
I never did find out how to get a landline.
.014 for the Pepsi.
Company told us it
You shut up.
That was too funny.
Nokia, no one has a landline.
Okay, we'll leave it at that.
Phones.
The technology here is no different
Now,
than ours.
we're going to weigh the ingot.
And who has access to it? Definitely.
Aluminum weight ingot.
It's integrated into everyday life seamlessly. Everyone uses it all the time. It's
528.
impossible to imagine life here without it.
528. 528.
Let's see over here how the 3D code
528. So no matter which way I turn it, it's 528. And that's
applications that allow you to take a photo
in metric. We're in kilograms.
or whatever else. And through
Okay, I'll take it off and I'll do everything in pounds.
information relevant to that event, where it's playing, who's in it, the reviews it got. I can even reserve tickets, choose my seats, and make the payment right
Okay,
now. From the user's
cans .024. .032. .024.
Here, it's very common to tag your friends on Facebook. So
.024. Okay, so one Coke is .024.
set out a If you want to have a drink,
One Pepsi is 0.0232. Okay, so we got 0.032 for Coke, for Pepsi,
give me all the information I need.
0.032 for Coke,
So, with a picture of the code, I have access to the detailed bus schedule. I can also buy my tickets.
0.032 for Pepsi,
I just choose that and send a text message.
0.032 for Coke.
It's €2, which are automatically added to my phone bill, and the ticket is on screen here.
Now the aluminum ingot, 1.164,
Bus. Drivers don't check that, but once in a while,
1.164,
all I have to do is show my phone. It's my ticket.
1.164.
The fins are very honest, and that's a bit
So
bizarre.
let's see ingot.
Even for short distances, people
That's in
get on the
pounds.
tramway, pay for the ticket, and get off at the next stop or two.
Let's see if it was worthwhile melting 100 cans to get pure aluminum. So let's see what the internet has to say about what the cans should be weighing and how much aluminum you should recover from that many cans. So let's start by looking at the weight of the ingot itself. So the ingot was 0.528 kilograms, and it shows that the same what we got on our scale, it's 1.14 pounds by this one. Now, if we look at this other conversion program, it says here that our 1.164 pounds is equal to 0.52798 kilograms. So now we have another discrepancy. Let's try converting kilograms to grams. So 0.014 kilograms equals 14 grams. That's metric. All right, now let's go to pounds. See how many grams we got from our 0.032 pounds. And this here shows 14.514955584 grams. That's a lot of difference. But I think we're going to be going to pounds measurement anyway. I'm not much for metric, so. But there you have another discrepancy. So we're going to have to change it all to grams. And that would be the weight of one can, and then times it by 100 to find out how many grams. And then convert back to ounces, I guess. Well, no, this is getting totally out of hand. You got ounces to pounds. I could select either way to convert. Either ounces or pounds. In the orange here, I have pounds. So I've got pounds to convert 0.032. And if you look at the bottom down there, it says converting 0.032 pounds equals 0.512 ounces. Okay, now let's go here. And now we're converting kilograms to ounces. So we have 0.014 kilograms, and it converts to 0.494 ounces. How the hell did that happen? Why are they different? It doesn't make any sense. I use the highest number weight for both pounds and kilograms on the scale. And nothing is matching. 0.014 kilograms shows 0.494 ounces. 0.032 pounds shows 0.512 ounces. So either this measurements are fucked on the internet or something's wrong. I gotta figure out what it is before I can go ahead with this. That might be me missing something, or I don't know right now. I have to research a bit. Let's see if this statement's true. It says here, and how many aluminum cans in a pound? 1 pound of aluminum cans equals approximately 32 to 35 empty 12-ounce cans. We're using 355 milliliter cans, which is equivalent to 12 ounces. Today, the average weight of an aluminum can is about 14 grams. Well, we got one measurement that says 14 grams, the metric, from our weight, and from the American pound weight, the measurement we have for a can is 14.5 grams. So this says 32 to 35 empties should make a pound. Let's see if we can figure that out and see where we come to, or what we come to. So it says here, 1 ounce equals 28.34952 grams, or 28.35 kilograms. I don't know. Anyway, so we had 14 grams, and they said 35 cans should equal around a pound. They went 32 to 35. I only took the highest. So 14 times 35 is 490. That's total grams. So let's divide it by the amount of grams in an ounce, which is 28.34952. Okay, equals, so that's 17 ounces. Yeah, 16 ounces. 17.2842432.606 ounces. Wow, that's about right. It's a little high because there's 16 ounces. So American pound. All right. Well, we'll use this kilogram to grams because it says 0.014 kilograms equals 14 grams. So we'll go by that measurement. So we have each can weighs 14 grams. Times that by 100 for 100 cans, 1,400. So it's 1,400. Let's divide that by how many ounces? So there's 2.8.34952 grams in an ounce. So what's that equal? That equals 49.383552173 ounces. Divide that by 16 for poundage. 6 equals 3.084. Let's just round this all off to 3.09. So 100 counts should equal 3.09 pounds. Let's see what we got then, how much we lost. Now, our ingot, aluminum ingot, weighed out at 0.528 kilograms or 1.164 pounds. All right, and according to the calculations, what's on the internet, that's how much those cans should have weighed total. That's not eliminating the paint and the protective coating inside the can, and any evaporation from heating the pot for too long before pouring out the aluminum. So, and whatever the junk was left in there. Its proper name is dross. Dross is actually aluminum oxide. All right, we'll get to that later. So I took the total weight of all the cans. That should have been from our measurements and according to the internet. So for 100 cans, total weight in pounds should add it up to 3.08647201 pounds, or you can round it off to 3.09 pounds. Now our poundage that we came out with of pure aluminum was 1.164. So when you minus that from the total, we lost 1.92247201081 pounds, or pretty well close to 2 pounds. So again, I mentioned that the dross and the slag affect a lot of that weight loss. The paint and the coating, the protective coating inside the can, I don't think it amounted to much, but still, to only get 1 pound out of 3 pounds, approximately, that's a big loss. So, let's look up the scrap metal prices in BC. Okay, here at the top it says aluminum, $1.73 a pound. $1.73 a pound. Well, I got just over a pound, so let's say I got about $2 worth in that ingot. So I could have sold those cans for $5. 5 cents a can times 100. But instead I melted them down. I wasted propane, time, and a lot of monkeying around for nothing. So lost $3 on all those cans. That's aluminum. And that's the highest price I see in BC. Aluminum alloy is $1.60. Being ingots, knowing BC scrappers, cheap bastards, they definitely would probably only give me $1.60 if that. Now let's look at some other aluminum prices per pound. So you can see there's some pretty low prices here. I think the highest price is about $1.61 here for a certain type. Oh, there's one $2.80 for aluminum radiators. For the whole damn aluminum radiator, $2.80. Jesus, what a ripoff. Yeah, well, imagine maybe if I hang on to that aluminum long enough, maybe because of tariffs and stuff like that, that might start being worth more than cans. But I freaking doubt it. So, anyway. So that's what we got. So my advice, okay, and then we're going to talk about the slag or whatever. And of course, when you sell the whole can, that's included in the can. And I'll show you what it says about that on the internet. When you take your cans in to the recycling place, you get 5 cents a can, and they use the whole can. The dross or slag is called aluminum oxide, and that picture is what it looks like, which is the junk I had in my crucible after I did all my smelting. And it's recycled also, so it's products that can be made with the residue is over here. So in the blue there it says paint, dye, concrete, explosives, and fertilizer. So nothing in that can goes to waste, except maybe the paint that evaporates and the inside protective coating that evaporates out too. But everything else in that aluminum can is recyclable when you take the whole can in. So I think it's a much better idea to take the whole can in and try to smelter it yourself and lose all that extra stuff that's a byproduct of smelting, all that aluminum oxide. So there you go. My project about smelting aluminum and selling aluminum ingots compared to taking the cans into the recycle depot and selling the cans is being completely one-sided. Take your cans in, recycle them. Don't try to smelter them. It's a waste of time and a lot of money. Well, the last time I took cans in to be recycled, I got 5 cents a can. I guess I'm totally outdated on that, because now, according to this article, it says that cans are now worth 10 cents. So it says this means you can earn 10 cents per container on all these recyclable beverage containers, aluminum cans, and so forth. So I guess I lost $8 on those 100 cans that I melted down to make an ingot, aluminum ingot. So yeah, not a very profitable thing to do. Think about it. So I checked other places on the internet to see if that is true. You get 10 cents return on cans, aluminum cans, because the internet has got a lot of discrepancies and lies. You can't trust anything unless you can double check and see if the facts are the same. So here it shows that aluminum cans are worth 10 cents, and then plastic bottles 10 cents, plastic cup 10 cents, Drink box, 10 cents. Gable top, 10 cents. Glass bottle, 10 cents. Bimetal can, 10 cents. Drink pouch, 10 cents. Bag in a box, 10 cents. Liquid plastic container, 10 cents. Liquid glass, 10 cents. Alcohol bag in a box, 10 cents. And then you have liquid glass non-refillable bottle or beer, 10 cents. Ceramic bottles, 10 cents. So, yeah, I definitely lost a lot of money melting down that ingot and going by pure aluminum metal prices at the scrap yards. Well, that's it. Confirmed. Okay, bye.